Good morning, I'm Sarah Peters, and I'd like to welcome you to the Information Week News Desk, coming to you live at Interop in sunny Las Vegas. As you may or may not know, Information Week and Interop are tightly integrated with the mission of connecting the IT community in person here in Las Vegas and online at informationweek.com, networkcomputing.com, and darkreading.com. During the next 2 days, we will be talking about some of the key themes coming out of the show. We'll also talk to IT executives and researchers and practitioners about their challenges and pain points. You'll be able to watch this broadcast on and around the show floor, as well as see it streaming on the Information Week site. We are also going to dabble with Facebook Live, so you'll be able to see some segments on our Facebook feed. Now, this is day one of the news desk. We have already had 2 exciting days here at the Mandalay Bay, so let's recap what has been happening at Interop so far. Now, on Monday and Tuesday, we hosted the Dark Reading Cybersecurity Summit, which is a crash course for IT professionals who need a general understanding of all things security. That's where I spent all my time, and I can tell you it was a lot of fun. We also hosted a number of technical workshops on IT transformation, Internet of Things, software-defined networking, and containers, among others. Action-packed. Meanwhile, at the Four Seasons here in Las Vegas, Information Week hosted the Elite 100 conference on Monday and Tuesday. Hundreds of CIOs and senior executives got the opportunity to imagine what a state-of-the-art digital enterprise would look like and learn from some of the country's top CIOs on how they transformed their own organization. CIOs from FedEx, Capital One, the Weather Company, UPS, and others discussed trends and accepted their Elite 100 and Information Week Decade Awards. We'll talk a little bit later today with Editorial Director Susan Nunziata and Information Week Conference Chair Brian Galuli about the conference and what happened at that event. And if you didn't know, it is 30 years that we have had Interop. How have we even had IT without Interop? Just imagine where we were 30 years ago. All of these companies behind me that didn't even exist 30 years ago. How many of you didn't exist 30 years ago? How do we survive without Interop? I can't even believe it. So what we'd like you to do while we're doing this, tweet at us using the hashtag Interop30years. What has been some of your favorite moments or least favorite moments in IT over the past 30 years? I can tell you that my favorite was my speak and spell that I had about 30 years ago. It was great. And we'll read some of our favorites during the broadcast over the next 2 days. In the meantime, let's get started here. I am thrilled to be here with my first guest, Dr. James McCaffrey of Microsoft Research Labs. James has a PhD from the University of Southern California, a BA in Cognitive Psychology and Applied Mathematics, and an MS in Computer Science. So he kind of knows what he's talking about, and he's going to explain to us how machine learning systems can effectively use data to make all kinds of predictions. Dr. McCaffrey, thank you so much for being here with us today.
Thanks for having me, Sarah.
All right, machine learning. We hear a lot about it, but let's just start out with a definition. What is it?
Well, you know, that's an interesting question, and there's no standard definition of machine learning, so I simplify it. And in my world, the larger picture is data science, and that falls into 2 buckets. Classical statistics, which many of us took in college, with means and averages. But the other end is machine learning. I consider that more modern stuff where the goal is easy, make a prediction. If you're making a prediction, it's machine learning.
Now, you're going to be focusing on neural networks in the session that you're giving this week. Now, neural networks, I always think, of course, of neurology and brains, and some brains are better than others. Mine's kind of not so great. But I'm sure that brains hooked up to machines is not exactly what you're talking about. So explain to us what that means as well.
You know, neural networks are fascinating. In my talk that I'm going to give here at Interop, I'm going to demystify what they are. Because the first thing that anyone finds when they search for neural network on the internet is horribly complicated math equations with Greek letters. Turns out that a neural network is just a really fancy math equation, where the math equation is very, very loosely based on an idea of how brain cells are connected. So the term neural network really does have meaning, but it's better to think of a neural network as just a complicated math function that's a very powerful way to make predictions.
Okay. Now, I mostly cover security, and I can immediately see the value of something like this from security applications, being able to predict what is malicious, because attackers are constantly changing. They're just tweaking a little bit, changing what they're going to do. Is that something that machine learning is being used for in neural networks?
Absolutely. That's sort of one of the killer applications for neural networks, and one of the reasons why there's been increased and renewed interest in neural networks is in security. It's very tough to identify a malicious payload. Other neural networks can be used to make predictions at all levels through the technology stack of an IT enterprise, all the way down to predicting what servers are going to be hit next by requests, all the way up to making predictions on things like sales data at a high level. So neural networks are very powerful, and one of their beauties is that they can predict at all different levels. If you have data and want to make a prediction, a neural network is often the way to go.
Okay, well, everybody has data.
Yeah.
Most of us have way more than we really even know how to. We have more than we know what to do with. So if I want to take advantage of this technology, where do I start? I mean, do I need to buy products? Is it more of a system of processes that I can just implement, or what?
Yeah, I remember we talked about this earlier, and there's no good answer in the sense that it's a matter of opinion. In my opinion, in fact, this is going to be one of my major points of discussion at the talk, it's my belief that an effective neural network depends on a collaboration of people who really understand the data, people who really understand how neural networks work, and also people in the organization that understand sort of the data at a more strategic level of what it is we're trying to do. There's no magic bullet of buying a product, plopping it onto your corporate network, and pressing a button, say, go, make predictions. That's not going to happen.
Okay, so let's talk about that first thing you said about people knowing the data, because I've heard this a lot, and I think a lot of people in IT wish that they knew their data really well. But would you say that if we want to make this kind of thing work, we need to go to people maybe in the lines of business and ask them how their data works, or what? What's step one?
Yeah, you hit the nail on the head. It's a good example, well, maybe not a good example, but one example is trying to make a prediction of a sporting event. Like we finished off the National Football League season not too long ago. And it's all too easy to get a neural network tool from somewhere and then just pump every kind of piece of info or data from the National Football League in there, and then try to make a prediction, but it's not going to happen. It requires somebody who understands what data is important, what data is not, what data is redundant, because redundant data actually makes the prediction worse. So I totally agree with you that if you want to use a neural network to make prediction in the IT environment, you've got to start with the people who know the data, and then also the people who know what it is exactly that we're trying to predict.
Okay, one other question, just so I understand this machine learning a little bit better. How close are we getting to how our own brains work?
That's an interesting question too. There's been some research, especially done by DARPA, the Defense Agency projects, where they're trying to take neural networks to the next level and actually create physical representations of a human brain. Right now, the state of the art is they believe that they've been able to create an artificial brain / neural network that has roughly the intelligence of a honeybee. And it's an exciting area of research. Yeah.
Well, it's interesting because I was speaking to somebody at a conference recently who was just getting me to think more about how humans learn, how you feed us a lot of data, just a lot of random information, like that's a dog, that's a dog, that's a dog, that's a dog, without giving us the parameters of why that is a dog. And eventually you can go to a dog show and you recognize that they're all dogs even though they all look completely different, and that's not generally the way we do things with computers, that we try to define all the parameters. And so as we're going through machine learning, are we changing the way that we're teaching machines to learn as well?
There was an interesting result out of Google not too long ago, where they attempted, they successfully taught a machine to play the game of Go. It's sort of like Japanese checkers on a vastly more complex scale. And instead of using traditional techniques, what they did was they just, I don't fully understand it, but from what I read, they just took that approach and just threw massive amounts of positions at the machine, said this is a good position, this is a bad position, and so on and so forth.
Right.
Instead of trying to teach it rules on how to play the game. And the system that resulted turned out to be extremely powerful. And this could have implications. It's not clear yet whether that's going to be generalizable to other kinds of problems, but it was an interesting approach.
Well, my last question then for you is, what are you working on next? What's happening at Microsoft Research? Are you allowed to tell me about that, or what are you allowed to say?
I can't say too much, to tell you the truth, but I can say it's incredibly exciting.
Okay.
We're doing stuff where, I've been in the industry or computer science for a long time, and the pace of change just seems to keep accelerating. My colleagues at Microsoft Research, I'm more on the engineering side, where I help some of my smarter colleagues develop prototypes. The things that they're working on are unbelievable. 10 years from now, imagine what the world was like. I grew up before we even had ballpoint pens, before handheld calculators, before Xerox machines. Think about what the world is like now. 10 years from now, we're going to look back here at Interop 30th year anniversary and go, I can't believe how much things have changed.
I'm looking forward to it. As long as I still have a job and it's not being done by somebody with artificial intelligence, I'll be delighted to be here.
Okay.
Dr. McCaffrey, it's been a pleasure having you. Thank you so much. And we will be right back at the Information Week news desk at Interop after the break.